Hello to anyone who's stumbled upon this video and has decided to watch it. Basically, I'll try to make this as non-boring as possible because I notice that I tend to be pretty dull in my videos here. Hopefully, I'm not like that in real life, although maybe I am. It's hard to tell. But anyhow, this is a video that I want to kind of give praise to an author on pluralsight. His name is Vladimir Korakov. I might be pronouncing that wrong, but on pluralsight, he's got several courses, and he's a very, very smart guy. I think he's also a domain-driven design evangelist. Pardon my pronunciation there. But if you look here, he's got several courses, and a lot of them are geared towards domain-driven design and techniques to make you a much more aware and cognizant software developer. So in the last year or so, I've been doing a lot of outside of the, in addition to the cloud stuff that I've been exploring, outside of work, I've been doing a lot of exploration of containers, orchestration, microservices, been checking into serverless. It's all fine and dandy. It's really exciting technologies, and it's a lot of fun to look into. One of the common reoccurring themes, when I'm putting together containers or looking into those or thinking about how you would orchestrate and scale a system composed of different containers, which people refer to as microservices, so it doesn't have to just be containers. But one of the key quote unquote tools or techniques to do an effective microservices is to organize your applications in such a way that they're split out by a single responsibility per service. And a very effective tool in doing that is domain-driven design. Although it's not required to do that for a microservice-based architecture, it sure makes your life a lot simpler. And it just seems to be one of those really natural fits to going about doing a design. So I can go more and more into my thoughts and what I've been learning about DDD. And by the way, I am not an expert in any of this. I'm just really enthusiastic about the concept. Years ago, when I went from procedural development into object-oriented development, I pretty much had the same enthusiasm and excitement shift, going from one paradigm to another. And I would consider the transition from a monolithic-based architectural approach to designing things to a more domain-driven design approach. I would consider that to be just as exciting and just as, shall we say, intense as it was back in the day, 25 years ago, when I was going from procedural to object-oriented development. But anyways, long story short, because I do tend to ramble on, back in 2003, Eric Evans wrote a book called Domain Driven Design. And back then, I just kind of brushed it off and blew it off, because back then I was doing Java programming, test-driven development, things of that nature. And we were all familiar with doing the whole client-server monolithic-based application development. And although that's okay, I'm not going to knock monolithic applications and say they're bad, they're horrible and all that. They work. They've been making companies millions and millions of dollars. Programmers have had successful careers, doing creating monolithic applications and all that. There's many of them successfully running in the cloud. So I'm not going to be here to say that those are evil, although others may have a different opinion than I do. I will say, having looked at domain-driven design and learning a lot more about it, it's a totally different approach. It's like a 180 approach from the monolithic style. And whereas the monolithic applications tend to scale vertically, if you do it in such a way where you create and break out the monolithic into smaller services where each service have a single responsibility, and as well as their own domain, as well as their own database, as well as their own interfaces, as well as their own teams that do development on them, you can put them all together and they can all interface with one another, usually using RESTful services as well as message-based uh, services like RabbitMQ or other messaging platforms. Even I've not worked with it, but Apache Kafka and some of the other things too. Um, those types of systems tend to be much easier to scale, and I believe they also provide a lot of benefits. You can have different languages for each of those services, such that you have different um, programmers with different skill sets can create many of them in their own different languages, so you're not tied to one particular platform, especially if you use containers. So anyways, this isn't really a lecture or a explanation on that, so I'm kind of rambling, so I better stop short. But what I will say though is domain-driven design was written in 2003 by Eric Evans, and for many years it seemed like it was just kind of stagnant, not used. And this article here in 2017 kind of indicates that, domain-driven design is even more relevant now. And I watched a really interesting video with Eric Evans where he had kind of explained some of his thought processes as to why there's all of a sudden, after, literally 13, 14 years of writing that book, why there's become, quite quite an interest in it. I think a lot of it has to do with microservices architecture, and just the benefits of doing domain-driven design for that. The other thing is the tooling has gotten so much better, the hardware and the platforms. We have the cloud now, we have containers, we have orchestrations, we have serverless, we have all these new concepts that are here today that were not there yesterday back in 2003 when he wrote this. So, having said that, I think he was way, way ahead of time. It's almost like he just, Nostradamus, a prophet or whatever, and something he wrote literally close to, 16, 17 years ago, all of a sudden is becoming so relevant today. So now that I got all of that stuff done, um, I'm just going to go into a real small aspect of domain-driven design. One of the benefits from it, and one of the anti-patterns that you can pretty much solve. Domain-driven design has the anti-pattern of an anemic domain model. And this course by Vladimir Korov is it just rocks. It's an excellent course, and I really respect the guy because these are the kinds of courses that, as a developer, a lot of times, it's not always the most fun thing to do. It's an acquired taste. You just kind of have to get yourself in that mindset. And when I say fun, it's just some of the developers, that I know, myself included, like to just touch all the really neat, cool tools and technologies, the new languages, JavaScript thing, async and await, things like that. Hey, we want to get our hands dirty and start working with that. This, on the other hand, kind of takes the approach of how you would write software in general. So it's language agnostic, and it requires almost like a different part of your brain to think. Instead of technical, this kind of requires more of a software development / design approach, which for many of us, I don't want to use the word pain, but it involves more work. It involves more thought process. It's kind of like you step back, and when you're doing an object-oriented design of something, you have to step back and think about your classes. You have to think about your interfaces, what's going to be an interface, what you can derive from, how do you want to do encapsulation, things of that nature. Um, So I really respect Vladimir for creating these courses, and maybe this is a sales pitch for Pluralsight or his courses alone, but he also has a blog which is really worth visiting, as well as a kind of a mailing list subscribing to. So having said all that, I will get into what this particular course is about, and I won't give away too much of the code and stuff like that, because I would highly recommend taking that. So an anemic domain model, for the most part, is in DDD lingo, it's not a good thing, but that's not to say you can't keep developing successful software for years down the road using anemic domain models, and pardon my stuttering there. So in no way, shape, or form am I going to say anemic domain model is bad from this point on forward. You should forever throw away all of your existing software, monolith and all that stuff, and go straight to DDD. No, I'm not saying that at all, but I would like to kind of explain my thoughts if you're going to adhere to a system using DDD and a ubiquitous language and a bounded context, where you're using aggregates, entities, and repositories and all of those things, you do want to pay particular attention to making sure that you do not have anemic domain models. And I'll just kind of quickly demonstrate what those are. And by the way, the code I will use or show you is actually the code which is a part of this particular course. So I am not going to take any credit for any of this. The gentleman that deserves 100% of the credit for this whole video and inspiration and all that is this gentleman, Vladimir Korakov. So I'm sorry that I probably pronounced his name wrong again. But the code is written in C#, which is language that I myself am familiar with. And basically, I am going to give you, let me open up the code here. I had to start up my Visual Studio there, so I apologize. I'm going to kind of give you a before and after, just to kind of demonstrate an anemic domain model and what you could do to turn it into what is known as a rich domain model, which is basically the end goal. It's the end game. It's what you want when you're doing systems based on domain-driven design. So here's kind of a before and after. Shall we say, in Web API land, this is a .NET Core application itself. But in API land, where you've got your controllers and all of that, those who are familiar with doing it, we have all done this, myself included, and I'm still doing it even today in some of the existing systems at work, because we have not moved towards DDD at work. But here's an example. Like, it's an API call. It implements your GET. And how many times have you seen this in code? And I'm not going to say this is bad, evil, and all that, where you're returning a list or you have a GET with an ID. And what you end up returning, basically, in this example, is a customer object, but it's an entity. And the entity itself pretty much models our database table. So if you look here, we have our customer table, and then we have our columns. So we've got our name and email and status expiration date. Pretty much what we have here, and many of us who have been doing a lot of this development with ASP.NET, we've been taught this. This is, a good thing that we can go ahead and, take advantage of validations with these annotations and all that. But what we end up doing is, in our controllers, and with the point that they're trying to make, is we end up returning an object back to the client, which is pretty much a mirror of our database table. Some of the problems with that approach is it makes it awfully hard, especially if you've published your APIs to different clients, customers. It makes it awfully hard to implement schema changes, things of that nature, because now all of a sudden you have to change your model, and you want to make sure that you're the model you're returning now all of a sudden may contain or exclude some of the new attributes. It could potentially break some of your client's code. Granted, if it's one application, if you have just one screen, one UI, okay, so just you take a minor hit there. You just have to change your one client. But if you're publishing this and you have clients, customers, and all that are dependent on your API, this could lead to a lot of headaches. So this customer object that I'll bring up, this is known as an anemic model. And the reason why it's anemic is there's several reasons. You have public attributes in here. So you have attributes without functionality. And again, in many cases, it's not a bad thing. So in many of our systems, we tend to separate our data models with quote unquote classes that we call services. So here's another example. So what you're looking at here is the non anemic approach, where all of a sudden we have a set of functions that we put in a service that will actually act upon and the data that are in our different model objects. So if I go to customer, you can see this is an anemic model. If I go to movie, you can see that this is an anemic model. And movie, again, here's another table. You've got columns, you got your name and licensing. So I'm hoping you can see that although this is not, we've been doing this for years and years and years with success and companies making money, all of this, it does open the door to some problems. Some of the other problems with actually having services that act upon and touch your model is you can leave your model, you can leave your objects basically in a inconsistent state. So these are invariants that are not met basically. And one of the purposes, or one of the main goals of DDD is you want to make sure that your domain objects are in a consistent state at all times, quote unquote, that they're valid within the context of a transaction or all that. When you have these separate objects floating around with all these public attributes, at any given time when you get this object back, you have no idea how they got set. You have no idea if this object is even in a valid state per se. So that's kind of the thing that you have to deal with there. So when you go from this approach to the DDD approach of changing your anemic model into a rich one, this customer object that you see right here has basically morphed into what you see here. So now all of a sudden, we have a customer object that actually has data as well as behavior. And so next question you might be saying, so this customer object, as you can see, has grown by leaps and bounds. And so your next question might be like, well, you don't want to be passing this back and forth between your controller and to the client. And most certainly that's 100% true. So what the course teaches you, and one of the other things that you want to do, is this customer object that you see here, which has turned into this rich model. This is your domain model. This is your part of your domain core. And your domain core is actually protected and should not really be referenced by the outside world, aka sent back to your clients and such. You don't want your clients knowing, external clients knowing how you've implemented your internal domain core. So this basically represents a part of your business that has the most value. What you end up returning back to your clients is not the customer object anymore, but a DTO object. And so these DTOs basically look like they're anemic for the most part, and that's fine. These are contracts. These DTOs are contracts by which your outside world communicates to and from your system through an API, or shall we say an application layer. So in DDD lingo, your core domain objects like customer and movie, for example, let me bring that up if I can find it. There we go. As you can see, this is the movie one, and it's grown. And again, if you take that course, he will walk you through all these examples and explanations, and he does it in an excellent way. But the idea now is these movie and customer, these are a part of your domain core, the most important thing in your business that you want to protect. It is the part of your business that makes you money, which you end up exposing to the outside world in your controllers and such now are your DTOs. And basically, the advantage of doing this now is your schema changes, all of those kinds of things, that your database changes, data type changes, all of those kinds of things, you know, shall we say, are covered by your repositories and your entities and dealt with by your core. No longer are you exposing any of those kinds of changes to attributes and all that to the outside world. All you're exposing is a facade. So if you're big on the Gang of Four and the regular design patterns, the facade pattern is one way to kind of think about this. I don't want to say it's the adapter because, well, to me, this is more like a facade. So it's kind of a wrapper around some of your true domain objects. So the other advantage of doing that, again, is it protects your objects. So that's one of the key things here is your APIs now will be receiving DTOs inbound and passing DTOs outbound. Another common thing that we do in the quote unquote monolithic systems or things that we're used to is functions like create. See how we do well, first of all, see how we do a get and we're returning a list of customers. And then we have the whole HTTP post when we're trying to create a customer. You look here, we're passing in the object again. What about an update? Again, we're passing a customer in. And then here's an example where we are, purchasing a movie here. We're doing stuff to the customer. For the most part, what if, and here's a common situation that he exploits, which is really good. What if in the update, you only are allowed to update just two elements of your customer record or your object right here? Let's just say you're only allowed to update money spent, for example, or one of these other fields. Well, if you are going with this particular approach where you're taking an incoming customer object into your update and you end up calling, you end up passing the whole object into your repository, for example. In many cases, the way we do our repositories with ORMs using Entity Framework and such, in many cases, an operation like this is going to save everything coming in. Well, what if you only really want to update one or two fields? Granted, on the client, maybe your client is only updating those two fields and passing the whole object in or whatever. You run the risk of nulling out some of those other objects, or even worse, you can have a mischievous client that's actually going to go ahead and figure out, hey, even though you're only intended to update two attributes, I can change money spent or whatever to something that I'd like, even though we're not typically allowed to update that money spent. Since they're not protecting for it, I can just go ahead and assign a value to it and just use Postman or something else like that. This causes a security. It's kind of it's a security issue that can cost you quite a bit of money. So again, that's one of the drawbacks of an anemic model where you're dealing with stuff like this. So check this out. This update method that he has here, this is really cool. has now morphed into another DTO. Notice the DTO coming in here is a totally different DTO, update customer DTO. And we got a create customer DTO here for the create. But what does the customer one look like? Well, if you take a look at that, in this example, he's only allowing you to update just the name. So you can't update the money spent, you can't update other attributes on the customer object because in this particular application, it's illegal. So money spent actually is going to be updated by some other internal process behind the scenes. The only thing that this application is letting you update is the name. And that's one of the advantages of passing these DTO objects in, is now if you're working with this item and you're basically, what we're doing in this code right here with these factories is we are ensuring that only the name and nothing else is going to be processed on the update method inherently. So you get a layer of protection there. If you look at the create, a totally different DTO here. What you end up here is you can create a customer with just a name and an email, and then the other attributes behind the scenes are going to be defaulted inside of the repositories. I'm not going to show you the code to there, but just know that the other attributes will have default values associated with them, which is fine. So you're looking at this and you're probably saying, well, that's a lot of work because you're creating a lot more classes if you look here. And that's true, but to be honest with you, I don't see that as a bad thing. In some aspects, it is a good thing to have different classes representing different types of operations and different types of contracts coming in for what you're trying to do. So when you're creating, you can only create a customer with a name, with the name and the email. So why let them pass you the whole customer object that has all the rest of the stuff that could get you in trouble? Not only that, but from a maintenance standpoint, when you start looking at this approach right here, the old approach, when you look at the controllers, and it's something we're used to as coders, we don't really know. A lot of times we have no idea just by looking at the create, all of the valid attributes that it is on a create. You kind of have to go through the code and figure out, okay, what it is, what are the attributes that you can modify on the create, and what are the attributes that you can modify on the update. All of that stuff goes away, and it's almost like reading, I want to say, it's almost like reading diagrams and flowcharts when you start using DDD in this case. The other concept with DDD, and not so much an anemic model thing, is the concept of value objects. So instead of dealing, value objects are pretty powerful concepts too. And although this is not a part of a domain model per se, or a rich model, it's really, DDD fundamentals, and it just makes your domain models even more rich. Here's the old version. So as specified for the customer entity, we have a name and an email. They're both represented in our language by string, and that's fine. Vladimir makes a great point that, so you have a string, which is your email, and a string, which is your name. But because it's a string, not all versions of a string would constitute an email, and not all versions of a string would constitute a name. So looking here at the money spent, we have this represented as a decimal. And so he poses a question, does a decimal will allow you to have negative and positive numbers and things like that. Does it make sense to have a negative amount for your money spent? No, it doesn't. But because we're using native types here, we could potentially put a negative value in there, even though it doesn't make sense to have one. So the whole concept of a value object, or one of the main concepts of a value object, is if you look here, we got money spent, email, and name. Take a look at this customer object. This is the after version. So what we have here right now, money spent now, instead of that decimal, it's this class, this external class called dollars, which is using a decimal behind the scenes with an implicit conversion. And also our name, which was a string before, is now this customer name in this email. And yes, you're probably looking at this and saying, wow, that's a lot of work. Is it really worth the effort? And I would almost argue, although I'm not an arguer, I'm a very passive person, I feel, I would almost argue that for a very complex system that you're going to be doing a lot of development with, and it's going to be generating a lot of revenue and things like that, a system that you need to basically be sure that it's going to work for a long time and be relatively easy to follow, I would say yes, it is definitely worth it. So if you take a look at this customer name value object, what you end up having is, there's a base class that's a value object, and inside of there you can create a customer name from an existing string, and it's going to actually perform the validation for you. So these value objects are actually ensuring integrity for you at the same time that you're creating them, and you can pass them back and forth. You can perform comparison equality just by right here. We've got an implicit conversion operation right there on our customer name, which is pretty nice. So it just reminds me of my C++ days where you have your operator overloads and all that. So you can go ahead and use syntactic sugar in your application to start, shall we say, treating these value objects as you would a native object. Just trying to look at anything else here. So as you can see right here, it's where we're creating our emails. I could get into a lot more, but I think I'll probably stop there and just highly recommend that if you have pluralsight, you definitely check out Vladimir's courses, because they are worth a ton, and they're excellent courses. And also, keep in mind that one of the major goals, and it's a legitimate acronym, keyword, buzzword, if you will, you don't want anemic models inside of a domain-driven based system application. You want to make it as rich as possible, so you have data and functionality back and forth, and you're encapsulating and you're bringing all of the responsibilities into one place that specific object can do. So I think I'll stop there. I really appreciate you watching this, and I'm sorry if I rambled on. I realized the first few minutes had nothing to do with an anemic model, but again, I was just making this up as I went along, but I hope this convinces some people to start taking a look at this. It's really exciting stuff. So have a great one, and thanks again. Bye-bye.